All right, ladies and gentlemen, welcome. I'm so glad you tuned in. You might have clicked this by accident, but oh, you're stuck here. My apologies. Hey, we're talking about, we looked at chemical reactions earlier in the quarter, but now I just want to get you guys knowing like what's really taking place, okay? Because next year, when you get to eighth grade chemistry, you're going to have to be balancing chemical equations. So you're going to get just a slight little introduction today, and I just want you to know some aspects of chemical reactions and what's taking place. So first off, all right, I got some Play-Doh here. All right, I'm wearing gloves. Yes, I am wearing gloves. You might think that's a little ridiculous, but you know what? This Play-Doh that I'm using is like glittery. Okay, I don't know why I bought this kind. It's glittery, and I don't feel like smelling like Play-Doh and having glitter from the Play-Doh on my hands the rest of the day. All right, so here I have this plate. Okay, you know what? I started. This is what came into the tub. Maybe I smash it like a pancake. All right. Wow, I hope I have pancake. Tomorrow's Saturday. I'm really hoping to have some pancakes for breakfast. That would be awesome. All right. Or maybe I roll it into a ball. Okay. I'm gonna roll it into a ball. All right. Maybe I stretch it. Okay, snap it into two pieces. All right. Or three. Or four. I'm making a mess. That's ridiculous. All right. But you know what? At the end of the day, I still have, oh, this is all crumbling everywhere. I still have the same amount of Play-Doh. All right. No matter what, I'm going to end up, as long as I don't eat some, okay, I'm going to end up with the same amount of Play-Doh into the container that I started with. No matter what I do to it, okay? Cut it up, rip it into little pieces, whatever. I can do whatever I want. Okay? Hey, that is similar. It's like a little representation of the law of conservation of mass. Okay? That's a lot to say, the law of conservation of mass. But what it's saying is that matter, okay, and mass, because matter is anything that has mass, right? And takes up space. So mass, it's not created or destroyed, but rather it's transferred or transformed into, again, another form. All right. So think about it like that Play-Doh. It's still Play-Doh, okay, but just in different forms. Okay. Same thing with chemical reactions. All right. We take certain elements, okay, and when you mix them together, we're going to go into like the different like wording for those. Okay, we get something new, but guess what? We still, at the end of the day, have the same amount of stuff. Okay, now that might not make sense to you right now, but that's okay because we're going to dive further into it. All right. So again, we have our law, right? Law of conservation of mass. I'm sorry, you're getting a major glare there. Okay, and this also refers to matter. Right? And it's not created, it's not destroyed. Okay, like that Play-Doh, right? I didn't I didn't gain Play-Doh or lose Play-Doh, right? I just transformed it into different types, and that's exactly what happens in chemical reactions. All right. Now, a couple key terms that I want you to know. I actually don't have them here, so maybe you can jot them down on the side here. Okay, we have our reactants. All right, hopefully that all fits in the picture. Great. And we have our products. All right. The reactants, okay, that's what's going into a chemical equation. What is reacting? Okay, what is reacting, right? We also have our products. What is produced? Okay, so an example, just to make it concrete for you, the reactants in a recipe would be eggs, sugar, flour, right? If I'm making like a cake, right? Egg, sugar, flour, right? And my product would be the cake, okay? What's produced, okay? After, well, again, baking is an example of a chemical reaction. So I just kind of want to show you that reactants, they react together, okay? Combine, their atoms are rearranged, they change shape, they change into different substances, right? And we get a brand new final product. All right. So with that in mind, let's continue working through here. So when we see a chemical equation, actually, I'm going to throw one up on the board here right now. All right, these probably aren't going to be real smooth transitions, but we're going to make the best with it. All right, so here we go. I have, again, a very simple, all right, chemical equation that probably many are familiar with. Okay, so we have our sodium, okay, Na, plus Cl. Now it's chlorine gas. Okay, so plus Cl2. yields. Okay, we have a yield sign. So this is on the, by the way, this is on the back page or the second page of your notes. So my yield sign here. Oh yes, the mighty, mighty yield sign. Okay, that's breaking up the reactants and the products from each other. Okay, so this yields NaCl. Okay, but let's see here. We're going to get chemical equations. Okay, as they must be balanced. Okay, that is the critical factor. Chemical equations must be balanced, like your diet. Okay, a well-balanced diet will lead to good health. Okay, so again, a well-balanced diet, that's just an ice cream cone in both hands. All right, that's well balanced. Right, you don't want to get too many scoops and fall over. Okay, if you get my joke, it's funny. If you don't do anything. Okay, now I got sodium plus chlorine yields NaCl table salt. But this we're going to see actually is not balanced, right? Because look at, maybe I have, let's say I have one sodium atom here, okay? Chlorine, I have two. Now you're probably thinking right now, like, Sue's like, wait, what's that? What's that two? What's that stand for? I'm gonna go back to that here in just a second and show you what that's called. It's called a subscript, okay? Yields NaCl. So there's one sodium and one chlorine, but hold on, there's two over here, right? That does not seem very balanced to me. All right, we need two here. So I'm going to throw what's called a coefficient. I'll go over that in just a second. Right out front here, giving me now two chlorines, but oh snap diggity, it gives me two sodiums. How can I balance it out? Oh yeah, you guessed it right. We're going to throw a 2 coefficient in front of Na for sodium. Now we got 2. Oh, that is well balanced. By the way, folks, if you want to try a little balancing activity, while I take a pause this video, and I paused myself. Stand on, take turns going on your left leg and right leg, and just pause, try and balance, and then I want you to close your eyes and balance. Okay, so you'll see it's probably going to be a little bit difficult because we rely on our vision as one of the aspects that keeps us balanced. Okay, so we're going to go back to the notes here. So here we go. And we're back. It's like we never left. Okay, so here we go. So there's two different parts. Okay, so we're learning some different, I guess, the features of what a chemical equation looks like, right? So we have our reactants, or what goes into our products. So maybe here I'll just put R, or some reactants. Maybe I have two things. Maybe I have three things. Okay, and we have our good old yield sign. Okay, it yields, produces the product. Okay, and it could be more than one thing. It could be two things. It could be three things. All right, so equals our products, and that's, so there we go. Reactants, products, yield sign. But there's a couple other things that are going to be in a chemical equation I want to break down here. So we will have, all right, what are known as subscripts. All right, and boy, I wish I had a sub right now because I haven't eaten in about, well, it's been too long, about 8 hours. I'm starving. Subscripts, they show us how many atoms, all right, how many atoms of an element are in a molecule. How many atoms? Okay, so going back again into our earlier chemistry. Okay, so for example, we have some high quality H2O. Okay, some water, and so these little subscripts, folks. Here's how you're going to remember it. A subscript. Okay, think of submarine, right? Submarines are submerged underwater. They're down below. So our subscripts, okay, are located down. They're real small, right? We write them down, we throw them down below, okay? And since they're small, really think of atoms, right? Super, super small, right? They tell you the number of atoms, right? So the two, it always refers to the left, okay? So there are two atoms of hydrogen, okay? Oxygen, there's nothing there, all right? So it's like in algebra, right? We don't say 1x, right? It's just X, right? We saved it. Technically, this water is H2O1, okay, but we don't write the one, okay? We don't write the one. I also just realized I'm still wearing these gloves. I have no idea why. 2020, folks. All right. So there is one atom of oxygen. Okay, so two atoms of hydrogen, one atom, or excuse me, did I say hydrogen? Yeah, two atoms of hydrogen, one atom of oxygen. Okay, submarine. Think submarine subscripts are located down below. All right, so there's something you might see in a chemical reaction. You may also see what is known as, so I should probably provide another example here. Okay, KNO3. All right. So how many? This three here. Okay, this three. This subscript is referring. He refers just to his buddy, oxygen. There are three oxygen atoms. We can think of a little imaginary one here with N, and a little one with K. Okay, for potassium. Okay, K potassium and nitrogen. All right, there's little ones there. So this little subscript just for his buddy O. Right. So now, if there's parentheses, that's a whole different ordeal. But we're not worried about that right now. All right, so let me pause here. All right, from subscripts to the larger, the coefficients, ladies and gentlemen, the coefficient. Remember to write neatly because you guys actually have to be able to read this, okay? The coefficients, right? And that shows us how many molecules, okay, or moles. All right, you'll talk about moles in high school chemistry, so we'll just, for simplicity's sake, we'll say we'll just say molecules, right, that are in a particular chemical or substance. Okay, so going back to our water example, right? Here, okay, I actually made a mistake. Your paper has like a three out front. Okay, so what's that saying? That three out front, again, the coefficient tells us how many molecules we have. So here we go. We have the water molecule, and there are three of them in this case. Okay, there are still two. All right, we still have a little two here for hydrogen. All right, hydrogen atoms, but now actually, so we actually now have six hydrogen atoms and three oxygen atoms. Let me kind of show you why. So if we have H2O, 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 okay, we have three molecules, okay, three water molecules. We now have three times two, we have six hydrogen atoms, and we can check them off here. 1, 2, 3, 4, 5, 6. Oh, snap diggity. All right, here we go. And for oxygen, we should have three, right? Because the three coefficient out front, that ties for the whole molecule. So there should be three oxygens. 1, 2, 3. Okay, so we are good there. And again, I want you, ladies and gentlemen, to remember that no coefficient or subscript means that it's a 1, and you guys are all number 1. Everyone's number 1 here at LVMS. Okay, so again, just to show you, if I had CO for carbon monoxide, okay, there's nothing here, nothing here. All right, so we could say it's C1O1, but it's just easier to say CO. Okay, CO. So nothing, no subscript means just a 1. And here's the last thing. I appreciate you sticking with this video. I maybe should have chopped it up, but we're going to keep it as one video here again. So again, we have our reactants. Okay, what goes into a chemical reaction, right? It yields. Okay, here's our yield sign. All right, yields, it produces, it gives us the products. Okay, and remember the law of conservation of mass, the LOCOM, okay, the LOCOM, the law of conservation of mass. That mass and matter is not created or destroyed, it's just transformed, okay? And we can maybe see this here. All right, we have two hydrogen gas molecules, right? 4 total atoms of hydrogen, all right? And 2, put X's, for the oxygen, okay? Let's see. So again, this should be balanced, right? Our reactants should balance out with our products. So how many oxygens do I have over here? 1, 2. That's cool. How many hydrogens? 1, 2, 3, 4, as the Kool-Aid man says. Oh yeah, right? We are balanced. Let's go. I would probably run through this whiteboard right now like the Kool-Aid man, but yeah, probably going to get a major concussion. All right, I hope this helps to wrap everything up, folks, with your notes. And again, just a little preview, little wrap. Okay, the little submarine subscript, okay, tells you the number of atoms. There are 1, 2 oxygen atoms. And our coefficients, right, they are out front, our coefficients. And that tells us the number of molecules, 2 hydrogen gas molecules, 1 2. All right. I only get 15 minutes for these, and it's at 14:55. Uh-oh. I gotta run, folks. Bye. Hope this helps. Peace.